Have you ever wondered, if you traveled 1 light year, how far exactly would you go, and where would you end up? You might assume you arrive at another star, or maybe another planet, or basically something waiting for you on the other side. But the strangest part is that almost everything interesting or frightening happens long before you even get there. So what actually happens during each stage of that journey? What do you cross? What disappears? What changes around you? And what is waiting at the end? That is exactly what we are going to walk through today. And I'm telling you right now, the last point on this list is the one that almost nobody thinks about, and it completely changes how you understand what space actually is. Let's start with something that sounds almost impossible. Within roughly the first half day of a light-speed journey, you would cross what we call the edge of the solar system. Light takes about 8 minutes to reach Earth from the Sun. Neptune, the most distant planet from the Sun, is about 30 astronomical units away, so a beam of light passes Neptune's orbit in roughly 4.5 hours. A few hours after that, you hit something called the heliopause. The heliopause is the boundary where the Sun's magnetic field and the interstellar magnetic field meet, and beyond it, the Sun's protective plasma bubble can no longer push back the surrounding interstellar medium. Voyager 1 entered interstellar space at about 122 astronomical units from the Sun, becoming the first human-made object to make it possible. Now here is where the number gets crazy. 1 light-year equals roughly 63,000 astronomical units. That means the entire heliosphere, this massive bubble that contains every planet, every moon, every asteroid belt we know, takes up only about 0.2% of the 1 light-year journey. More than 99.8% of the trip happens beyond the Sun's protective plasma shell, in what is technically already interstellar space. But here is the twist, and this is mostly the important thing I want you to hold on to for the rest of this video. You see, crossing into interstellar space does not necessarily mean you have left the solar system. Those are two completely different things, and the reason why is going to change everything you think you know about where our solar system actually ends. So let's keep going. After the heliopause, you are floating in interstellar space for the overwhelming majority of the trip. No solar wind, no protective magnetic bubble, just you and the raw interstellar medium. And yet, you may still technically be inside the solar system. For understanding, solar system is often used to mean the space or the area out to the very last planet. But scientific consensus says the solar system extends out to the Oort Cloud, which is basically a spherical swarm of ancient, icy objects that surrounds the entire planetary system at an enormous distance. It is believed to extend from the Sun out to approximately 100,000 astronomical units, with some estimates reaching as far as 150,000 astronomical units. Doing the math, you'll be surprised to find out that outer edge sits somewhere around 1.6 light-years from the Sun, so at the 1 light-year mark, you might still be inside it. Now, do not picture this as some dense asteroid field you have to dodge through. The outer Oort Cloud is thought to contain roughly 1 trillion objects larger than a kilometer in diameter, but they are spread across an almost incomprehensibly large volume of space. The gaps between individual objects would be enormous. You could travel through it and never see a single comet. It would take Voyager 2 about 300 years to reach the inner edge of the Oort Cloud, and possibly about 30,000 years to fly beyond it. When you really think about it, our fastest spacecraft, launched nearly 50 years ago, would need 30,000 years just to clear this region. And at 1 light-year into the journey, you might be sitting right in the middle of it, surrounded by distant comets still gravitationally connected to the Sun, with the planets impossibly far behind you, and the nearest star still more than 3 light-years ahead. So 1 light-year might not take you out of the solar system at all, but it might only take you deep into its most mysterious and least understood region of space. Beyond the outer edge of the Oort Cloud is where the gravity of other stars begins to dominate over Sun's gravity. Proxima Centauri is a small star located approx 4.2 light-years away from the Sun, which means traveling 1 light-year toward it gets you less than a quarter of the way there. Look forward and there is no glowing destination. No planet, no obvious landmark telling you that you have covered 9.46 trillion kilometers. Just dark interstellar space and a sky full of background stars that look almost identical to the ones you left behind. So you turn around, and what you see is something strange and genuinely moving. The sun is still there, but it no longer looks like the sun. It no longer fills the sky, no longer dominates everything. It has become a point of light, an intensely bright point, just like other stars. And somewhere next to that point, separated by a maximum of only about 3.3 arcseconds from your viewing angle, is Earth. Every human being, every city, every ocean, all compressed into a small, bright dot. The sun, from 1 light year away, finally looks like what it has always been, just another star. The difference is that you would know exactly what is sitting beside it. And here's something that most people never think about when they imagine this journey. The space you just crossed is not empty. Interstellar space contains neutral hydrogen, charged particles, cosmic rays, and microscopic grains of dust. At that current speed of the spacecraft, individual particles are not a serious problem. But at a fraction of speed of light, the physics changes completely. The spacecraft is crashing into particles faster than they can move out of the way. Hydrogen atoms effectively become a stream of high-energy radiation hitting the spacecraft's outer hull. Tiny dust grains carry enough kinetic energy to melt or vaporize surface material on impact. Research into proposed interstellar probes has found that gas bombardment could damage a spacecraft's surface, and dust impacts could create craters, causing melting and gradual erosion over the course of a long journey. Engineers studying this problem have proposed that an interstellar spacecraft would need a narrow, forward-facing profile, sacrificial shielding layers, and sensors capable of detecting larger grains far enough ahead to maneuver around them. The faster you go, the worse it gets. Speed effectively transforms the thin interstellar medium into a continuous stream of dangerous matter. So now you understand what you are crossing. But here is the final thing, the one I promised at the start, and it is the one that might genuinely surprise you. A light year is a unit of distance, not time. How long the journey actually takes depends entirely on how fast you are going, and the answers across different scenarios are absolutely different from each other. Voyager 1 is currently traveling away from the Sun at a rate of about 3.57 astronomical units per year. At roughly that speed, covering 1 light year would take somewhere around 17,000 to 18,000 years. A proposed laser-driven probe traveling at 20% of the speed of light would cover the same distance in about 5 years. Light itself does it in exactly 1 year. But there is a human travel scenario. If you accelerated a spacecraft continuously at roughly Earth's gravity, turned around at the halfway point, and decelerated for the rest of the trip, an idealized calculation puts Earth's measured journey time at about 2.21 years. The travelers on board, however, would experience roughly 1.89 years, because relativistic time dilation starts producing a measurable difference between the spacecraft's clock and Earth's clock at speeds approaching 75% of light. And then there is the communication problem. A message sent from the 1 light-year mark takes 1 year to reach Earth. Earth's reply takes another year to come back. Just one simple question and answer, 2 years gone. The travelers would not just be separated from home by distance. They would be separated by time itself, living in a bubble of delayed information where the world they left behind is already more than 2 years older by the time they hear anything back. Now, 1 light year sounds like the distance to another world, but in reality, it might just reveal how unbelievably large our own cosmic neighborhood actually is, and we have not even left it yet. So, if I have to put everything together and conclude, after traveling almost approximately 1 light year, you'd be far beyond the heliopause, surrounded by extremely thin interstellar gas and dust. And you could also potentially still be traveling through the outer regions of the Oort Cloud. If that blew your mind, share your thoughts below. And if you want to watch more deep dive exploration like this, make sure you are subscribed to the channel so you never miss the upcoming videos.